I'm demoing my learners for my project too. So, I'll start out with the DT learner. So all of them kind of had the same structure. You have your init method that basically makes the learner, and then uh, this is a static method, so it's not part of the DT learner class because it needs to be called um before you actually make the DT learner, so it wouldn't be able to be in the DT learner. Um, but then, so basically you have one if statement. This is if I use my new data sets that I imported for my creative assignment, and then, or you can load a data set from a CSV file, and you can change that with this parameter right here. Use sklearn dataset. So this is where you're selecting the feature to be split on. And because this is a DT learner, you're splitting based on the best feature. And, you know, you have to use the evidence to find your best feature. And then uh, you're building the tree based on what features you're using. Um, and then this is just querying after you made the model. And then here is where um, I'm getting my metrics for all the models. And then right here, you can use this classification to, um, you know, because you don't want classification metrics on a regression model. So you can change that right here. And then this is how I build my tree, just visualizing it. Uh, and then, yeah, I used PL2 to do that. And then this is how you test the tree, but um, I'm not really using that. I'm using the metrics. So I will demo it for you. This is going to be with the California housing data set. So this is a regression data set. So I will have use sklearn data set as true. And then down here, classification is false. So, and then here is my tree visualized. And then here are all the metrics for the data, RMSE 7.6. In sample, out of sample, in sample mean squared error, um, out of sample mean squared error. And then I can demo it with the other data set, which is cover type, which is a classification data set. So we will go down here and then change the metrics classification for true. Then use sklearn data set is going to continue to be true. Do that. And I'm building these trees with a max depth of 4 and a leaf size of 2. Those can be adjusted based on how you want them. And then here's my tree right here. Then I have a confusion matrix for the in sample data or out of sample for right here, and then in sample right here, precision, recall, and then F1 score. So that's it for the DT learner. Main difference in the RT learner is how you select your feature. The RT learner, it's just going to be a random feature, whereas in the DT learner, you're actually picking a feature. And then, select build the tree the same, add evidence, query the same, process the data set the same, and then test the model the same. So, and then visualize it the same. So here I'll demo it with, let's see, the California housing data set first, which is a regression, so classification is false. So it's the tree. You have ensemble, root mean square error, how to sample, and then that. So now I'll go down and change this. Right. Cover type data set and save that. Classification equals true. There's a tree. Have two confusion matrix, precision, recall, and F1 score. Right now they're pretty low because just the tree isn't really that big, and this is a large data set. So, but for the sake of time, I'm just gonna leave it like that. And then over to the bag learner. Uh, Same init method. Actually, no. You have different parameters, but you have an init method. Same way to process the data set. Um, you're adding evidence a little bit differently because you're bootstrapping the sample. This is how to query it. And testing the model is basically the same. Visualizing the tree is more or less the same. And then testing it, I'm not using right now, but it's there. So here we will demo it on using the DT learner, but you could use the RT learner or basically any learners that you want. You can import them and then use them. So, yeah. And then the data set is going to be the California housing data set. So that is classification. It's a regression, so classification is false. And then this max depth is 3 and leaf size is 1 as well. So trained on 10 bags with the boot size strap of that. Here's the tree. And then I have root mean squared error, same whole deal. Now let's try it. Cover type. So bags 10, classification true on that one. So it might take a little bit longer. I'm going to train it with, for the sake of time, only 3 bags. Change this to 3. Save on that. So yeah, here's the tree. Have same whole confusion matrix, and this, then all you have to do to use the RT learner is just RT dot RT learner, save that, then run it again. Do basically the same thing. So, yep, that's the project.